Welcome to this video. Today we're going to look at bending a pipe, the same shape as you see there. Just running my hand along the profile. We're going to copy that bend and fit it to that flange there on our left hand side and over to the one on the right. So we're going to follow that same contour along. I'm going to show you how to do it. First way, if you're on your own and you want a pipe length, just put one hand on your tape measure, the other hand just follow the tape along, and that holds it in place and gives you, when you get to the end, the length of the pipe that you're requiring. In this case, only an approximate will do for what we want. We can trim the pipe at the end, but we'll start from one end and work our way along. For threading the pipe, we're going to use this manual rigid threader. It's got 1/2-inch dies in it, and as you can see from the way I'm working it there, it can ratchet back and forward. It's got a guide. That's the guide we're putting on that side. Where my hand is, that's where the cutting dies are. And you might notice a little knob on the top there. If we pull that out and reverse it, that will reverse the ratchet action on the tool. Just put a bit of forward motion onto the die box there, the die head, and just ratchet the handle up and down, and those dies will bite in and start cutting their way along the pipe fairly easily. You may have noticed I used some cutting compound on it too, so wipe some cutting compound around the pipe before you commence threading. Thread your way along until you get to the end of the pipe. So you look on the front of the dies. When you've got a full die threaded onto the pipe, it's time to stop. So just reverse the action, unwind the threader. Put some thread seal tape onto the end of the thread. Now we're going to fit a flange onto it. Before we do that, put some thread seal tape around it. Just helps with the sealing between the pipe thread and the flange thread. And just get the flange and thread it on. Here I'm using a handy spanner. It's just one which has been made up, but it's got a cutout on it which allows the spanner to fit over the pipe or around the pipe. It's got 2 drive dogs on it which fit into the bolt holes, and just pulling on them allows you to spin the flange around into position. It's a handy tool to have if you have to adjust flanges while the pipe work is all bolted up or connected up. It allows you just to throw the spanner around the pipe and get into the bolt holes and turn the flange around to line it up a few degrees if it's just misaligned slightly. We're using a pipe vise there. Just position the flange that you've made on top of the flange. Put one bolt will do if you put it on the back, and just hand tight it up. Don't need to nip it down with the spanner, but make sure you've got all the slack out of it. Get a tape measure and measure from any convenient place. Now, There I'm measuring from the floor, or from the top of the tabletop, to the center line of the pipe. You always measure to the center line of the pipe. And there I'm just going onto that frame that the former is welded to and checking up the height there. Whichever way you use it, make sure you use the same dimension. I'm going from the frame now, vertically up that pipe, and putting a chalk mark on the measurement that I originally got from the center line of the other pipe. So I've got a clear chalk mark on there. Important thing to remember here is, although I've put that mark on the pipe, that is not the mark that we're going to bend to. Instead, what we have to do is take the diameter of the pipe. In this case, it's a 1/2 inch gal piping. If we measure the outside of it, we'll find that it's about 21, maybe 21.5 millimeter. And that's the distance that we now have to come back from that chalk mark in the direction of the flange, mark back a distance of 21 millimeters and put a new chalk mark there. Also, just looking at the bender that I'm using, it's got the former, which I had out there. It's clearly marked on the former the size of pipe that it's suitable for bending, in this case 1/2 inch. And the rollers there, I've got the pins through them. They are also marked, so they must go into their set positions on the yoke attached to the hydraulic bender. Now here I'm just marking that new mark at 21 millimeters back from the original mark. When I feed it through the yoke on the hydraulic bender, there's a slot right in front of me there. I'm looking straight down onto a slot in the center of that yoke, and I line that mark up with the center of that. Since we're using chalk to do our markings, we're obviously not going to be correct to 1/2 millimeter or even 1 millimeter perhaps, but try to keep it as accurately as you can, even though we're using chalk, because the closer we get to our dimensions, the better things all work out when it comes to the final job and bolting down flange to flange. If we're a bit sloppy with our marking out, then the result is going to be pretty sloppy too. Here I've got a rafter square, and I'm putting a rafter square just in the apex, so sighting it up just with the slot in the bender, getting the apex there where my thumb is basically on the rafter square holding it. And then I'm going to keep pumping the hydraulic ram until those legs swing around and come just visually what I think is in line with the two legs of the rafter square. What you need to do is just stand back, check it by eye, be as critical as you can. Now, when I've got it in line with the two legs there, I'm giving it a couple of extra pumps, maybe 2.5 maybe, because the spring, when I let go, that's the relief valve I've just released on the hydraulic ram, takes the pressure off the pipe, or off the former that's bending the pipe. And when I release it like that, the pipe, you'll notice it springs back. It probably springs back a couple of degrees. Now I'm going to fit it onto the flange again, put the bolt back into it, slide a nut on top of it, and then stand back and just check and see how that bend has worked out. Should be pretty close. If need be, just take the pipe back out of the flange, unbolt it from the flange, put it back into the pipe bender, and bend it a little bit more. Try not to go too far. It's more difficult, I guess, to straighten the pipe. If you go too far, you can basically only straighten it a couple of degrees by putting it in a vise and pulling it back. So try not to bend it too far. It's better if you bend it a little bit less. You can put it back into the bender and just give a couple more pumps and get it to where you want it. Now I'm trying to mark the second bend. It probably drops down about 30 degrees here. So what I'm doing is just using the rafter square, putting the edge across what I consider to be the center of that bend, and just putting a chalk mark on there, on the new pipe. Just sighting it up. Just unbolt the flange. We'll put it into the pipe bender again. because we're not bending 90 degrees, we won't get the same type of pipe stretch. So it's not necessary to come back the diameter of the pipe. However, I do come back about 5 millimeters. In other words, I do come back a little bit just to allow for a little bit of stretch and compression on the inside of the pipe. Taking up the pressure onto the pipe just with the former and the hydraulic ram, so that I can, as you see there, just make sure that that horizontal leg is in fact horizontal and nice and straight. And you can with a bit of pressure on the hydraulic ram, not too much, that allows you to move the pipe to the correct position that you want. Now, to get the bend, to measure the bend that or want to achieve, I'm using a bit of welding wire. In this case, I've got a bit of aluminium wire, welding wire, and just by bending that and tweaking it a little bit, you can get it so that you think it conforms fairly closely to the bend you want to make. Again, put the center of that bend into the center of the former or the yoke there. Just eye it up with the center of the slot and then start pumping the handle again. You can get these pipe benders with an electric motor, but because we teach a lot of students, they're not used to the electric motor and they can overrun it quite a bit before they realize they should have stopped it or released the valve. So the manual one is much better for giving you much more control over the pipe and what you're doing. Stops you going that little bit too far, as I said before, which becomes a real problem then to fix. Bring the pipe out of the yoke, set it back into the flange again, and just eye it up, see how you think things are going. In this case, I'm probably at maybe half a degree or so high, but you have to draw a line at where you think you need to maybe bend it a little bit more or let it go. You'll find that the pipe will spring a little bit. You can work with the pipe a little bit. In this case, I've decided that what I've got there will be okay. And the next thing I've got to do, of course, is just bring the straight vertical leg down now. I'm just positioning that flange because the flange wasn't correct for the bolt hole configuration, so I just used that special spanner there, pipe spanner, to put around it and just pull it into place. Just finger tightening the nut so we can get another good look at the pipe. You can see it there, it's probably sitting up a little bit, but in this case I don't think it's going to be a concern or a problem. Checking the center to center distance now to transfer a chalk mark onto the pipe so that we can start to work on the vertical drop on it. Again, from the former I took center to center distance. Always when you're dealing with the pipe work, it's center line to center line, not from the outside edge of the pipe to the outside edge of the pipe. It's always center line to center line. So we'll put this back into the pipe bender and see how we go. Just put a new chalk mark on there, probably came back about 10 millimeter, maybe 14 millimeter on that. Again, just to allow for the pipe stretch as it bends. Just put the bypass valve back in again. That allows the ram to extend. Again, just put a little bit of pressure onto the pipe to hold it in position before you decide the orientation of the pipe. Get it nice and straight. In this case, I need that leg nice and horizontal there. Just eye it up with the table or whatever. Just checking that the chalk mark is in place. and it's not, so I need to pull that pipe back a little bit, get the chalk mark exactly where I want it. As I say, you don't need to work to 0.5 millimeter, but at the same time you need to be as careful with your adjustments as you can be, and that will all work out for a better overall job when you're finished. Now what I'm looking at here is when the job is fully bent, what we need to achieve is a distance from both flanges need to mate up together. So I'm taking another dimension on the center line, center to center distance of the holes in the center holes in the flanges. And I'm going to use that measurement as a final check when I'm bending it now for this final, say 60 degrees or whatever it is that I've got to come around. So here I'm using the tape measure. I'm going to slide it across either under the ram or over the ram to try and get a bit of a fix on just that center to center distance of the two flanges, because that's the important one. Be as critical as you can be without being overly fussy. Just standing back and checking that the two legs look parallel to each other. If you're happy with it, bring it out of the former. Bring it out of the hydraulic ram and put it back into the jig, and let's have a look at how they both line up side by side. Got a bit of excess piping on that end, so just put one bolt in, and I can pivot it around and till it comes up alongside the flange, and then I'll just take a measurement and try to measure how much excess I need off the pipe to cut off the pipe. So just transferring a mark there level with the flange. You may need to measure it. Okay, so we've got the pipe back into the pipe vise or chain vise, which is just fitted onto a standard offset vise in the workshop. We're using a rigid pipe cutter here. You just spin it around as you do. Just adjust the handle on the end of it in. It tightens up the cutting wheel onto a couple of rollers that track around. And just keep doing that until the end of the pipe basically just drops off. Now that end has to be threaded like we did before. We use a rigid pipe threader for it. Put some cutting compound onto the end of the pipe. And just ratchet the threader on. Keep going until the pipe comes through just to the end of the dies, and that should give us a nice length of threaded pipe on which to fit the flanges. Just reverse the threader. Take it off and just get a rag and clean some of that cutting compound off the end of the pipe. Put some thread seal, Teflon thread seal tape around the threaded portion, and we'll just select another flange and screw that onto the end. Just use that pipe spanner to screw it on as tight as we can. In this case, I'm trying to line up the bolts now so that I get the correct configuration before I put it back onto the jig and put the bolts in it. I'll just line the holes on this flange up with the holes on the bottom flange. Just stand back and have a look at them and adjust if you think it needs to go a little bit more. Undo the chain vise and we'll take it back to the former, have another look at it. Next thing we're going to do before we bolt the pipe into position, we're going to make two gaskets. You can see there on the left some rubber insertion, and on the right composite fiber gaskets material, and we're going to cut a gasket for each end out of the two different materials there. How to mark out first the rubber insertion or the rubber gasket. Just cut off a little bit that's slightly bigger than the flange. Get a bit of soft chalk and just rub that across the face or the surface of the flange that we want to copy. And put the gasket material down onto that. Hold it stationary, don't let it move around. It's important that get your thumb and press it down into each of the holes. You want a good marking where the holes are. The center hole too, and then around the circumference of the flange. Get a nice mark around that. When it comes to transferring the other flange onto the composite fiber material, you can use the chalk, but it probably won't be such a clear marking. If you use micrometer blue, like I'm using there, and just put a smear of micrometer blue across the surface of the flange, then get a piece of the composite fiber gasket material and do the same as we did with the rubber insertion. Just hold it stationary, hold it steady, push down into the hole so you get a good transfer of marking from them. The center hole too, and then around the circumference. We'll take them across to the other bench where I've got a block of timber. Always use end grain of timber to do your wad punching on. Also too, you might notice I've got the block positioned above the leg of the bench there. When we're doing a lot of hammering, always put it across a solid, or put it on top of a solid part of the bench so that it can take the blows and transfer the shock to where you want it to go rather than through the top of the bench. Just getting the right size of wad punch connected to the driver, and then position it over the holes. One smack with a hammer is all that's required. Now we're still using that square piece of gasket that I cut out, I haven't shaped it to the round shape yet. The reason for that, if we cut it round and then I drive blows to form the holes, it can quite often break out to the edge of the gasket and form a crack in it, obviously. And we don't want any cracks in gasket material. In fact, our reason for making the gaskets is to prevent any leakage and so on, and to take up any cracks or irregularities that might be on the flange faces. So the same thing with this one. Now we'll change the head on that driver, wad punch driver, and we'll put on a larger one for the center holes. And lastly, composite fiber one. And so as you can see, we've got an intact gasket at this stage, so we just get the scissors, the industrial scissors, and just cut our way around that shape. Important too when we're making gaskets that the holes for the bolts are just slightly bigger than the bolts themselves, so you don't get any obstruction when you're trying to fit the bolts to it. Also, the center holes should be slightly bigger than the diameter of the pipe. You don't want any restriction to pipe flow. You don't want any turbulence being set up within the pipework due to gasket material protruding down into the actual bore of the pipe or the flow path of the liquid that's being transferred. Back at our pipe installation, just clean the flanges. And get a file and just run a file across the face of the flange to make sure there are no burrs or any irregularities on the surface of the flange which are going to prevent the gaskets from sealing correctly. Just position the pipework, and then we'll nip down the bolts all the way around. Because we're going to pressure test the pipework, I want the bolts to be torqued down to a specific torque. So we'll run around with a torque wrench after we've just nipped all the bolts into position. Pipework is one of those jobs in industry where in some shops a lot of pipework is done, pipe bending and pipe threading. In other places it's a sort of job that you never really see much of at all, if indeed ever. So this video is intended just to give people who don't do a lot of pipe bending an idea of just how to start, where to start, and how to go about it, so that they can end up with a satisfactory type of result. Here I'm just getting the torque wrench and adjusting the setting on it. I'm only putting a very low, the torque setting for these bolts should be about 50 Newton meters, but I'm just putting on 25 Newton meters, which is very, very low. So therefore, when I come to pressure test it, if there's any fault with my flanges or threaded screwed ends with the flanges put onto them, or the gaskets that I've made, it will show up because I'm going to pressure test this to 150 psi, or about 10 bar approximately. So now we've got a water pressure tester. Just going to connect that up onto the connection on the rig. Not going to drive that up too hard, but I will nip it up a little bit with a spanner. I'm not worried if I get a little bit of a leak out of that particular joint or connection. That's not the one I'm testing. I'm testing the pipe that I've just made. So what the water tester does is, when I pump the handle, it pushes water through the complete pipe assembly, and then I just keep pumping the handle. There's a gauge there just on the top of the water tester, and that tells me what the internal pressure is. So I keep pumping until I reach the 10 bar. That's the bypass valve, just screwing that in so that the water and the pressure goes straight into the pipework. Just go around each of the joints and check for any leakage. Everything seems to be okay around the flanges, around the screwed ends. Same on that side. And everything is good. If we're happy with the results, open the bypass valve. That will release the pressure inside. You can see it returning to the tank there below the pressure tester. And all that remains now, of course, is to disconnect the pressure tester and put away the tools. So I hope this is of some help to you if you've got a bit of pipe work to do. Give you some ideas of how to go about it. Thank you for watching.